Here we have a binomial squared in two different variables. We can write this out in expanded notation and use the FOIL method to simplify this multiplication, or use our shortcut that we looked at with a perfect square trinomial. So just to illustrate the FOIL method, first terms multiplied together, 2x times 2x is 4x squared. Outside terms, or the outer terms multiplied, 2x times 5y is 10xy. Inner binomials multiplied together, both positive, 5 times 2 is 10, x times y, xy, and L for the last terms multiplied together, positive 5y times positive 5y is 25y times y, or y squared. Simplifying by combining like terms, 10xy plus another 10xy is 20xy. And here we have our final answer. That's using the FOIL method, but the shortcut when we have a perfect square trinomial is square the first term. 2x times itself is 4x squared, plus multiply the first and second terms together. 2x times 5y would be 10xy. Double that for our middle term, and there it is, 20xy. And the last term is the square of the second term. 5y times itself is 25y squared. We have two binomials multiplied together here as well. And if we look at this, the first term and the second term are exactly the same, except one is a sum and one is a difference. This will result in a difference of squares. If we hadn't caught that, we would find that out by multiplying first terms together using FOIL method. 4x squared times y to the third times 2x squared y to the third. 2 times 2 is 4, x squared times x squared. Add those exponents for a fourth. Y to the third times y to the third is y to the 3 plus 3, or 6. When we multiply the outside terms together, positive times a negative is a negative. 5 times 2 is 10. When we rearrange and multiply our similar terms together, we have an x squared, a y to the third, and a z for the variables. Our inner terms, a positive times a positive is a positive. Integer multiply to give us a 10. We have a z, an x squared, a y to the third, which is just that, x squared, y to the third, z. And last terms multiplied together, positive times a negative is a negative. 5 times 5 is 25, z times z is z squared. When we simplify, these two terms cancel out. They're additive inverses, resulting in 0, leaving our first term and our last term. This is the difference of squares. To save ourselves the steps here with the FOIL, since the O and the I cancel out, we could have multiplied the first two terms together, which is essentially that first term squared. 2x squared y to the third times itself is 4x to the fourth y to the sixth. And square the last term, 5z squared is 25z squared. And the minus coming from a positive times a negative to save ourselves a couple steps, resulting in what we call difference of squares.